The Andromeda Nebula has been known to man since ancient times. The first to notice it were the Chaldean priests, astronomers of the ancient world. At some point in the past, the Andromeda Galaxy was the spitting image of our home, the Milky Way. But with the development of astronomy, this myth was dispelled. It turned out that the Milky Way and Andromeda belong to different subclasses of spiral galaxies, and the configuration of their arms is quite different. But nonetheless, they still have a lot in common. For example, an appetite for devouring their dwarf satellite galaxies. Their internal structure is also similar. The Andromeda Galaxy, also known as M31, looks like a spiral, the lines of the arms of which being evenly dispersed around the spherical bulge, the central, bright part of the galaxy, which consists mainly of old, bright stars moving in extensive, elongated orbits. The Milky Way today, on the other hand, is assumed to be a galaxy of the SBBC classification, a barred spiral galaxy. The difference between our galaxy and M31 lies precisely in the bar. This is the portion that extends from the edges of the bulge and connects it to the arms. The nucleus of the Andromeda Galaxy, like the nuclei of many other galaxies in the universe, has candidates located in them that have the potential to become supermassive black holes. Based on the results of calculations, the size of such an object could exceed that of up to 140 million times the mass of our Sun. In addition, the Hubble telescope discovered a mysterious disk which contained young blue stars surrounding supermassive black holes. They revolve around a relativistic object in exactly the same way planetary bodies do around their stars. Astronomers are a bit puzzled by how this kind of a disk could form so close to such a huge object. According to calculations, the enormous tidal forces of supermassive black holes should limit the gas and dust clouds from coalescing and forming new stars. Well, further observations will likely provide us with clues to this mystery. According to rough estimates, the Milky Way may contain between 100 and 400 billion stars. But this is nothing compared to Andromeda, which may contain about 1 trillion. Thanks to the Hubble Space Telescope, among this trillion, scientists have learned about the presence of a very large and sparse population of hot and bright stars. Hot young stars tend to appear blue. However, the blue stars found in the Andromeda Galaxy appear to be growing old, more like the Sun, stars that have burned out their inner layers and are revealing their hot blue cores. They are scattered all across the center of the galaxy and are the brightest in the ultraviolet range. Besides that, there are other interesting objects located in the core of M31. Along these lines, a double or a binary cluster of stars was discovered in the center of Andromeda Galaxy. This discovery turned out to be highly prized by the astronomical community, since the merging of the two clusters into one could happen over a fairly short period of time, roughly in about 100,000 years. Based on calculations, astronomers have determined that the merging should have happened millions of years ago. However, due to some strange and still inexplicable reasons, it did not happen. According to one hypothesis, there may not be a double cluster at all in the middle of M31, but rather something like a ring consisting of old red stars. The ring might look like two clusters, because when observing, we only see the stars from the opposite side. The ring of the disk is turned to our galaxy on one side, from which it can be concluded that there is a certain interrelation between them. When studying the center of the Andromeda Galaxy using the XMM Newton telescope, a group of astronomers also discovered 63 discrete sources with X-ray emissions. Most of them, that being 46 objects, have been identified as binary X-ray stars, whereas other objects are acting as neutron stars or candidates for black holes from binary systems. About 460 globular clusters have also been registered in the galaxy. The most massive of them, Mayal-2 or G1, has a luminosity greater than that of any cluster in the local group. It is even brighter than the brightest cluster in the Milky Way, Omega Centauri. It is located at a distance of about 130,000 light-years from the center of M31 galaxy and mainly consists of about 300,000 old stars. Similarly, the PA99N2 star is located in Andromeda, around which orbits the exoplanet, which is the first to be discovered outside the Milky Way. But as it stands today, the planet is still considered to be unconfirmed. However, in view of the scale of the Andromeda system, the presence of so many stars in it, and an even larger number of planets, it is quite possible, at least according to the logic of the theory of probability, that among this abundance of planets, there are planets that are quite suitable for life, or already have life on them. After hundreds of thousands of years, we will be able to see everything much better, given the fact that a collision of the Andromeda galaxy and the Milky Way is inevitable. Mind you, this will happen in about 4 billion years. We'll be substantially older. Well, we tried to put together all the most interesting facts about our celestial neighbor. If you want to find the Andromeda galaxy in the night sky, then the best time to observe it is the autumn and the winter. In a dark sky out of town, it will be visible to the naked eye. What's interesting is that because of the finite speed of light, we are seeing this object as it was 2.5 million years ago. Shall we say 2.5 million years ago on Earth, there were no representatives yet of the modern human species. Unfortunately, according to the theory of special relativity, there is no way to know what this galaxy looks like at the present moment, given that what we see is for us the present moment. Europa is the biggest moon of Jupiter, with a huge ocean beneath the surface. The satellite's water under a huge layer of ice does not freeze because of the hot core of Europa, which is heated by Jupiter's gravity. This became known in the early 2000s thanks to the Galileo probe, which detected marks of an electrically conductive liquid under the surface of Europa. It also discovered that the surface is made of ice and that it's one of the smoothest in the solar system. It might seem that this is where our knowledge ends, but this is not true. Over the past 20 years, and especially recently, we have learned a lot of exciting details about this distant satellite. We offer to ponder on some of them and reflect on to what degree this distant world can be alive. So Europa, also known as Jupiter 2, is the sixth moon of Jupiter, the smallest of the 4 Galilean satellites. It was discovered in 1610 by Galileo Galilei. Over the centuries, more and more comprehensive observations of Europe were made with telescopes, and since the 70s of the 20th century, with flying spacecraft. Europa is slightly smaller than the Moon. With a diameter of 3,122 kilometers, it is the 6th in size among satellites and the 15th among all objects in the solar system. It is the smallest of the Galilean satellites, yet the mass of Europa is greater than all known satellites in the solar system that are inferior in size combined. Its average density is very low, and this points to the fact that it consists mainly of silicate rocks and thus is similar in composition to the terrestrial planets. The tallest formations that can be found here are merely several hundred meters. If we take a close look at Europa's surface images, we will see signs of endogenous geological activity, such as lines, lenticles, bumps and pits, and the so-called Connemara chaos below the center. The high albedo of the satellite indicates that the surface of the ice is pretty clean and young. It is believed that the cleaner the ice on the surface of the icy satellites, the younger it is. Let's also pay attention to the plains. Smooth plains can be formed by the activity of cryovolcanoes, which erupt to the surface, filling areas with spreading and hardening water. From Europa's orbit, we can see a chaotic relief that has different geometric shapes. We can also observe areas which are dominated by lines and stripes, ridges, usually doubled, as well as impact craters. Their number is small. There are only 40 named craters over 5 kilometers in diameter, which suggests that the surface is relatively young, from 20 to 180 million years old. So Europe has high geological activity. The spectral analysis of the dark lines and spots of the structure shows presence of salts, magnesium sulfate in particular. The reddish hue allows to assume the presence of iron and sulfur compounds as well. Apparently, they are contained in the ocean of Europa and are ejected to the surface through clefts and then freeze. In addition, traces of hydrogen peroxide and strong acids were found. For instance, there is a high chance that Europa contains sulfuric acid hydrate. Let's land on that interesting object. As it turns out, it's not that easy. The thing is, Jupiter's moon Europa is surrounded by a region of sharp ice needles which stretches along the entire equator and is extremely dangerous for space probes to land on. Ice needles, also known as kelgospores in Europa, can reach up to 15 meters in height. Large as they are, these structures still cannot be seen on the images of Europe available to us so far. A few careful maneuvers and we landed. Phew! We managed not to damage our spacecraft by this gigantic icicle. The incredible view of Europe opens to our eyes. Its surface is very cold compared to the Earth. The temperature here is 150–190 degrees Celsius below zero, but that is not the main thing to worry about here. The radiation level on Europe is extremely high, as the satellite's orbit passes through the powerful radiation belt of Jupiter. The daily dose of radiation here is nearly 1,000,000 times bigger than on Earth. This dose is enough to cause severe radiation sickness. But no worries, we have a proper radiation protection. At least we hope so. Well, with this in mind, we are sending a tunnel robot with a nuclear reactor into the deep of Europe that could drill ice while collecting ice and water samples and sending information to the surface via fiber optic cable. Surprisingly, Europe has several layers of ocean, separated by different types of ice formed at different depths and under different pressures. It is likely that in each of these layers, different life forms might be found. Species that have adapted to the particular conditions of the ocean stratum may exist. However, if these life forms turn out to be unlike anything we have seen on Earth, it might be difficult for us to recognize them. And besides, we might not find life there at all. But these thoughts wouldn't stop our curiosity, would they? However, so far very little is known about how they formed and what is happening in them under the multi-kilometer shell. But all the same, the results of the survey were a real surprise to the mission's directors. No one had imagined that distant Pluto would not look at all like a smooth billiard ball, but would have an extremely complex relief, reflecting the history of its origins. In the new images, Pluto turns out to be covered with recently formed mountains, ice plains, methane ice dunes, and even icebergs drifting through nitrogen. In addition to that, the ice crust of the celestial body is strewn with countless cracks that looked like traces of recent tectonic activity. They were the first indication of the existence of a giant subsurface ocean on this dwarf planet. Soon other evidence emerged supporting the presence of liquid water under the planet's icy crust. But how and when it originated on Pluto remains a mystery to this day. But we now know that at one time, Pluto was originally cold. This means that it grew slowly, accumulating ice material from the outer solar system, and at first there was no ocean on it. Water in liquid form only appeared on Pluto after the core of the dwarf planet warmed up as a result of the radioactive decay of aluminium-26 and gravitational interactions with its satellite, Charon. In this scenario, geologic faults in the celestial body would have retained signs of surface compression. Why compression specifically? The fact is that the heat emanating from the depth of the planet would melt the lower layers of the ice, turning it into liquid water, which, as you know, takes up less space. As a consequence, Pluto's ice crust would have begun to contract, which would lead to the formation of distinctive geological traces. And what have we learned about Pluto's atmosphere and climate? Pluto's atmosphere is predominantly composed of nitrogen, with minor traces of methane, ethane, ethylene, and other gases. It is extremely thin. It has a pressure about 1,000 times less than that of the atmospheric pressure on Earth. Nonetheless, it has great influence not only on the climate, but also on the geology of the dwarf planet. For example, it facilitates the equalizing of the temperatures of the different regions of Pluto, and because of the greenhouse effect created by methane, the temperature of the planet's surface increases. Also, new data have demonstrated that some segments of the surface of the dwarf planet actually have snow caps, which are formed in a completely different way than they are on Earth. If on Earth, we are often able to observe the conversion of clouds into snow on mountaintops since temperature decreases with increasing altitude, then on Pluto there is conceptually the inverse process. Since the atmosphere there becomes hotter as the altitude increases, correspondingly, the physiochemical traits of the process of the formation of snow and snowcaps on Pluto differ dramatically. In this case, calling it methane ice is the most accurate conclusion. And finally, it turned out that the change of seasons on Pluto occurs not because of the tilt of the planet's axis of rotation as on the Earth, but is due to the elongated orbit. Over the course of a revolution around the Sun, which takes roughly 250 Earth years, the amount of heat received by Pluto changes almost 3 times. As a result, the density of the atmosphere fluctuates significantly. In the long summer, which lasts a little less than half of the Plutonian year, the frozen gases evaporate, and in the winter, they again revert to a solid state. They evaporate from the most brightly lit and warmed areas and settle in colder areas. This process ensures that gases are carried over the surface of the planet and over millions of years have sculpted the most amazing forms of relief. What comes next? New Horizons has raised more new questions for us than it has cleared up old ones. But most unfortunately, no new missions to Pluto are planned for the near future. So it will be a long time before we get new information comparable in value to that which was received from New Horizons. One of the moons of Jupiter, known as Io, played a significant role in the advancement of 17th century astronomy. Studies had shown that in the process of crustal compression, about 100 mountains were formed on the surface, changing the landscape over the next number of centuries. The peaks of some of these, for example South Busal Mons, exceed the height of Mount Everest twice over. Along these same lines, there are vast plains on the surface of this satellite. Its surface has unique properties and comprises an abundance of colors: white, red, black, green, and even orange. This distinctive characteristic is due to regular lava flows, which can stretch up to 500 kilometers. The high density indicates that there is virtually no water on this satellite, although there have been small pockets of water accumulation found. This deficiency of water is likely due to the fact that during the formation of the solar system, Jupiter was hot enough for volatile substances such as water to evaporate from Io's surrounding vicinity, although not hot enough for this to happen on the more distant satellites. Correspondingly, often found on the satellite's surface are volcanic depressions, just like in humans, although they are called paterae. They are characterized by an even floor and steep walls. They very much resemble terrestrial calderas. However, it is still unknown whether they were formed by the collapse of the magma chamber and the collapse of the top of the volcano, like their terrestrial counterparts. Unlike similar geostructures on Earth and Mars, volcanic depressions on Io generally do not lie on top of shield volcanoes and are usually larger, with an average diameter of about 41 kilometers, and the largest, Loki Patera, is 202 kilometers in diameter. It is remarkable, but paterae often serve as sources of volcanic eruptions or far-spreading lava flows, as in the case of an eruption in the Gish Bar Patera, or they themselves fill with lava, becoming lava lakes. The lava lakes on Io are covered by a lava crust which crumbles away and renews continuously. Image analysis has shown that the lava flows on Io are primarily composed of molten sulfur. However, subsequent ground-based infrared observations indicate that the flows are, in fact, composed mainly of basaltic lava and ultra-basic rock. An outstanding representative is Masubi, an active volcano on this moon of Jupiter, which is located on Io's leading hemisphere, in the Taurus region. The volcano is noteworthy for one of the largest lava flows, both on Io and in the entire solar system, covering an area of 240 kilometers. Despite the extensive volcanism that characterizes Io's appearance, most of its mountains are not volcanic in origin. The majority of them are formed as a result of compressive stresses in the lithosphere, which lift and often tilt portions of the satellite's crust, thrusting them over each other, much like giant ice flows. This is precisely why virtually all of the mountains of Io are at some stage of destruction, with large landslides being widespread at their bases. It appears that cave-ins are the main factor in the destruction of mountains. Believe it or not, but this tiny cheeseball, Io, plays an important role in shaping the magnetic field of the giant planet Jupiter. The magnetosphere of Jupiter absorbs gases and dust from the thin atmosphere of the satellite with a speed of 1 ton per second. All this matter, depending on its composition and degree of ionization, ends up in the various neutral clouds and radiation belts of Jupiter's magnetosphere, and sometimes even escapes Jupiter's system altogether. Also interesting is the fact that Io's moon is surrounded by a so-called atomic cloud of sulfur, oxygen, sodium, and potassium, which extends to a distance from its surface equal to about 6 times its radius. These particles come from the upper atmosphere of the satellite, and they are activated by collisions with particles from the plasmatores and other processes in Io's heliosphere, where its gravitational strength exceeds that of Jupiter's. Io's orbit runs its course within the radiation belt, known as the plasmatores, a donut-shaped ring of ionized sulfur, oxygen, sodium, and chlorine. The plasma in it is formed from the neutral atoms of the cloud surrounding Io, which is ionized and carried away by Jupiter's magnetosphere. It's not hard to guess that Io is not at all like most satellites of the gas planets, which contain huge masses of ice, as it consists mainly of silicates and iron, like the inner planets. Further still, its interior is also incredibly active. Modeling of Io's internal composition shows that at least 75% of the mantle consists of the magnesium-rich mineral forsterite, a composition similar to that of L-chondrite meteorites. It is obvious that the ratio of the concentrations of iron and silicon there is higher than those on the Moon or the Earth, but lower than on Mars. The latest research has shown the presence of an induced magnetic field on Io, for which an ocean of magma with a depth of 50 kilometers would be required. This layer is estimated to be 48 kilometers thick. It makes about 10% of Io's mantle, and its temperature reaches about 1200 degrees Celsius. It is not known whether this 15% melting is compatible with the conditions of significant amounts of molten silicates in this inconceivable ocean of magma. Io is a bright and wondrous world, which has no equivalent in the entire solar system. Active volcanism on a satellite the size of our Moon is absolutely astounding, and the pioneering photographs of the satellite surface, which have been obtained by a number of spacecraft, compel us to plunge again and again into the atmosphere of this distant and mysterious world. One of the places in the solar system that is worthy of notice and examination is located at an average distance of 250 million kilometers from us and stretches out for more than 1 astronomical unit. That is to say, the distance of the Earth from the Sun. This region is located between the orbits of Mars and Jupiter. As you may have already guessed, we are talking about the asteroid belt, a place where there is an accumulation of a variety of small celestial bodies of every possible size and shape. On May 3, 2011, a probe took the first photograph of Vesta from a distance of just over 1 million kilometers, after which an active phase of studying this asteroid began. By June 27th, the craft had slowed down, approaching closer to Vesta all the time. And after another month, having already made almost 2 revolutions around the Sun, the craft reached Vesta and switched to an orbit around it at an altitude of 16,000 kilometers. All of July, the craft was engaged in photographing of the surface of Vesta. The probe confirmed just how large the Rhea Silvia crater in Vesta's southern hemisphere is, about 500 kilometers in diameter and 19 kilometers deep. The spacecraft also revealed that the mountain in the center of the huge crater, which the Hubble telescope had once captured, is more than 2 times the height of Mount Everest and is the second tallest mountain in the solar system, taking a back seat to the Martian Olympus. Upon closer inspection, the probe found a second large impact basin, now called Venenia, that is partially covered by the younger Rhea Silvia basin. These 2 impacts changed the surface of Vesta and probably almost destroyed it. It remains a mystery how Vesta was able to survive such an extraordinary cataclysm. It is probable that numerous Class V asteroids, debris from the impact, were scattered in all directions. Giant impacts have created dozens of gorges encircling Vesta's equator that were revealed in the probe's images. Some of these canyons rival the Grand Canyon in size, reaching 465 kilometers in length and 4 kilometers in depth. The probe's data also reveals that the massive impact formed Rhea Silvia a mere billion years ago. Thus, the surface of the southern hemisphere looks younger than the northern, where a tremendous number of craters have been preserved. Previously, researchers thought Vesta was a substantially dry object, but the Dawn space probe detected water-rich minerals on Vesta's surface that are associated with carbon-rich material. These materials were presumably taken to Vesta by asteroids or comets from the outer solar system that is richer in volatile substances. On September 5, 2012, having completed an extended mission, the craft broke free of Vesta's orbit and headed toward the next object of research, Ceres, a transition which took 2.5 years. On March 6, 2015, having traversed a total of 4.9 billion kilometers at a distance of 60,600 kilometers from it, the craft was captured in the dwarf planet's gravitational field. And in early June, at a distance of 4,400 kilometers from the surface, the first photographs were already obtained. While the Vesta observations broadly supported the existing hypothesis and provided more details to fill in the gaps, less was known about Ceres. In fact, most of what we now know about the dwarf planet was provided by the Dawn spacecraft. Initial calculations suggested that Ceres might be separated into layers, although the composition of these layers was unknown before the probe. Given a low average density, Ceres was expected to have a large amount of water ice under its surface. However, the probe's measurements have confirmed that Ceres is actually composed of a rocky core and a crust of water ice, covered by a dusty outer layer. Dawn also uncovered evidence of the presence of clathrate hydrates, a gas trapped in the crystalline structure of the water molecules that makes the amazing strength and low crust density of Ceres possible. While a large portion of Ceres is relatively smooth due to its semi-liquid subsurface layer of ice, the spacecraft found a large mountain that it wasn't able to see previously. This mountain is about 4 kilometers high and is called Ahuna Mons. Its well-defined domed shape, similar to volcanoes on Earth, suggests that it was likely formed due to cryovolcanic activity. Although cryovolcanism may exist in other icy worlds, Dawn's observations make Mount Ahuna the closest known cryovolcano in the solar system. Other observations by the Herschel Space Observatory have shown small amounts of water vapor around several portions of Ceres, which suggests that it may have a weak atmosphere or even ongoing cryovolcanic activity. The probe revealed that this gas could be due to solar particles colliding with the water ice on Ceres, which is then released as vapor, resulting in a temporary, weak atmosphere. Spectroscopic data from Dawn also confirmed the presence of ammonia on the surface of the dwarf planet. Conditions in the main asteroid belt are too warm for ammonia to form, which requires much colder conditions, and which raises questions about its origins. Although mankind has already been observing the stars for many centuries, the question of whether we are alone in the vastness of the universe remains open. The chances of finding life elsewhere remain uncertain to this day, although it's safe to say that these chances are increasing, albeit at a slow pace. Since the discovery of the first exoplanets, researchers have been trying to determine which worlds are most likely to harbor life. For example, liquid water is essential for life as we know it, so an exoplanet that is either too close or too far from its host star is less likely to support life. But in this case, we are talking about life that we know, to which we are accustomed, and which we can fit into our head. As for space for make-believe, it can be found in the pages of the books of science fiction writers. A well-known work of the Polish science fiction writer Stanisław Lem is a book named Solaris, which was written in 1960. But in any case, how realistic is the planet Solaris? Could living creatures inhabit it? What are they? How plausible is this world? In order to answer these questions, I suggest that you, dear viewer, recall the main points of Stanisław Lem's novel, and in parallel, consider its feasibility. In summary, the story of the book takes place in a distant future in which humanity has long ventured beyond the bounds of the Earth and the solar system, exploring distant worlds and the hidden corners of the universe. Approximately 130 years before the events depicted in the novel, the planet Solaris was discovered, a satellite of a double star, which moves along a complex orbital trajectory around both of the luminous celestial objects of its system. This extraordinary orbit is far from the only oddity of the heavenly body, and it is far from being the most complex and perhaps most obvious. But more interesting, upon further study, it turns out that the entire surface of the planet is covered by a liquid, a dense, gel-like ocean, a substance that resembles a steady flow of jellyfish, living, and the motion of which defies explanation using science known to mankind. From time to time, complex phenomena appear on its surface, glinting the whole spectrum of the colors in the light of the radiating suns. The ocean attempts to imitate the flying vehicles of humans, and in some strange way affects the psyche of the astronauts themselves. Based on observations of the nature of Solaris, a completely new branch of scientific discipline was developed on Earth, solaristics. Eventually, scientists came to the conclusion that the ocean covering the surface of the planet was the one and only intelligent inhabitant of Solaris. It corrects the trajectory of the planet, affecting space and time in an unknown way. It also scans the minds and feelings of the people who are observing it. Enter the picture a space station of the same name in orbit around the planet, an artificial satellite on which astronauts, scientists, and researchers live and work. However, the enormous scientific discovery about the local ecosystem's ability to reason becomes the only breakthrough of solaristics, which quickly turned into a meaningless dead-end science. The most brilliant and ingenious minds of mankind turned into thoughtless freshmen with outdated microscopes studying Solaris. They were only capable of observing the intelligent ocean and recording its actions, but they were not capable of providing even the slightest explanation as to what was happening. A little later, the strangest things so far happen. In the truest sense of the word, the spacecraft becomes inhabited by the most realistic holograms or phantoms, the materialized memories of the people, someone possessing the appearance of those who were known at one time by members of the crew. Ultimately, the expedition came to the conclusion that the phantoms were the results of the actions of Solaris's intelligent ocean. While the people struggled in the attempt to find at least some reasonable explanation for its nature and behavior, the ocean in response studied the people, scanning their minds and thought patterns, perceiving feelings and memories in a mysterious way to create an illusion. What for? To play upon human vulnerabilities? To conduct a banal experiment from the category of "and what if"? Why did man decide that extraterrestrial intelligence was obligated to make contact? Does that person himself often tries to establish contact with ants or the moss on the trunks of pine trees? Does he seek to converse with the wind and the motion of the sea waves? Without question, Solaris's ocean is intelligent, but in its own way. What if all the life on an alien planet were one giant superorganism, as it was on Solaris? Astonishingly, many are accepting of this possibility. Such a finding may actually be the norm. For example, all living beings on Earth consequently combine together to form a huge superorganism, which with the help of self-regulation is able to maintain the critical parameters of the environment at a constant level. For instance, at differing levels of incoming radiation from the Sun, the surface temperature of the planet can remain at approximately the same level. As it turns out, top-quality science fiction is an important resource, as well as a resource of inspiration, for the theoretical work in the field of astrobiology. Now that we know that planets similar to the Earth are widespread throughout the universe, and that most of them are much older than the Earth, it is justifiable to pose the question, to what extent are the results of development on other such planets similar or actually comparable to the results that we see surrounding us? We also may well give consideration to an alternative macro-evolutionary path that could lead to the close functional integration of all subplanetary ecosystems, which as a result eventually leads to the formation of a true superorganism at the biospheric level. But that's a totally different story. Lost somewhere in the universe is a small blue planet, the third in order from a star called the Sun, one of the billions of stars in the spiral galaxy, the Milky Way. But where is the Milky Way located in the universe? A team of scientists has collected data on more than 8,000 galaxies in the outer space that surrounds us. They have mapped the positions and speeds of the galaxies, and for the first time in history, we saw that the Milky Way is part of a much larger system of galaxies, a supercluster, which they called Laniakea. Our galaxy is located in the outer reaches of this cluster. The entire universe is a sinuous network of galaxies, something like a cosmic spiderweb. Some regions are almost empty and look like dark cosmic voids, while others, on the contrary, are densely populated by galaxies in areas that are called superclusters, and these are perhaps the largest structures in the universe that we know. But here's the question. Think for a moment. Where are we really heading at a speed of 2.2 million kilometers per hour? Precisely the speed at which the Milky Way is moving in outer space. What is pulling us? If you have a ticket, then where it's marked destination, you'll read the name, the Great Attractor. Our galaxy, just like neighboring ones, is attracted toward a specific region of space, and it's about 150 million light years away. And here's the surprise, we don't know exactly what's there. However, the name of this mysterious anomaly has already been thought up, which is a great way off our shoulders. Yes, we are talking about the Great Attractor. In part, it's so mysterious because it's located in a region of the heavens called the Zone of Avoidance, which is situated toward the center of our galaxy. There is so much gas and dust there that you can't see very well or far in the visible light spectrum. The solution to the problem was the study of the clusters in the Zone of Avoidance. To study the hard-to-reach regions, X-ray radiation was used, which easily penetrates clouds of gas and dust. Clusters of galaxies are sources of X-rays, which makes observation and study easier. In fact, the Zone of Avoidance is currently quite well researched. Galactic gas and dust are also penetrated well by radio waves, as well as light in the infrared range. According to the findings of the study, fewer massive galactic clusters were found in the area of the proposed location of the Great Attractor than had been expected. However, a gravitational anomaly near the center of the Great Attractor, the Abell 3627 cluster, was strong enough to tear apart the spiral galaxy ESO 137001, or, as it is also known, the Jellyfish Galaxy, in the constellation of Triangulum Australe, or the Southern Triangle. As well, while researching the Zone of Avoidance in greater detail, it turned out that at the location of the Great Attractor, there is a large supercluster of galaxies called the Norma Cluster. Its mass is about 1,000 trillion times the mass of the Sun. It consists of thousands of galaxies, and although the Norma Cluster is massive and the local group's galaxies are attracted to it, it is impossible for them to fully explain the movement of the local group's galaxies, as the mass of the Great Attractor is not enough to generate such attraction. A study was conducted which made it possible to calculate that the Great Attractor contributes only 44% of the speed of the movement of the local group, with the rest being associated with the dark flow, where a significant region of the local universe, including even the Great Attractor itself, is moving in the direction of another object. Continuing the research, astronomers at the University of Hawaii have discovered an even more massive cluster of galaxies at a distance of more than 600 million light-years from the Milky Way, far beyond the Great Attractor. This refers to the Shapley supercluster, in which there are more than 8,000 galaxies, and it has a mass of more than 10 million billion suns, which is 10 times greater than the Norma cluster in the region of the Great Attractor. Out of the 220 known superclusters of galaxies in the observable universe, the Shapley supercluster is the most massive, and most likely, having reached the region of the Great Attractor, the Milky Way, as a part of the complete local group, will continue moving on further to the larger object, namely the Shapley supercluster. As usual, the logical questions then arise: what will happen to the Earth? What awaits humanity? In actual fact, No one really knows what this could mean or even if our planet is in danger. Astronomers say they will need a few additional years to learn more about this anomaly. Some specialists do not consider it a threat, while others insist that all galaxies and clusters will merge into larger and even larger superclusters, and that's how the universe will come to its logical end, the Big Crunch, which theoretically may well result following the expansion after the Big Bang. By and large, we have been able to distinguish that the Great Attractor is a gravitational anomaly located in intergalactic space. In fact, it is a collection of many galaxies formed and hidden away far off in the distance, and a large mass consequently causes the stronger attraction of other objects, to include you and I. What do you think of the Great Attractor? And what sort of hopes do you have that we will discover something new in this region of space into which our little blue planet is moving so swiftly? There are seas, mountains, dunes, although not from sand, but from heat-resistant organic matter. And when summer comes to the North Pole, it even rains methane. It's an amazing world. Indeed, we are talking about Titan, Saturn's biggest moon, the second largest moon in the solar system, after Jupiter's satellite Ganymede. It is the only celestial body in the solar system, with the exception of Earth and Mars, for which the existence of liquid on the surface has been proven, and it's the only moon on the planet with a dense atmosphere. The diameter of Titan is 5,152 kilometers, which is 50% larger than that of the moon, while Titan is 80% larger in mass than Earth's satellite. Titan also surpasses the planet Mercury in size. Although it is smaller than it in mass, the force of gravity on it is approximately 1/7 that of the Earth's. Titan's mass makes up 95% of the mass of all of Saturn's moons. Titan conceals many of its secrets, but today we will turn our attention to its amazing landscape. Now, the surface of Titan is composed mainly of water ice and sedimentary organic matter. It is geologically young and mostly flat, with the exception of a small number of mountainous formations and craters, as well as a few cryovolcanoes. For a long time, the dense atmosphere surrounding Titan made it impossible for the surface of the moon to be seen until the arrival of the Cassini-Huygens space research mission. Scientists suspect that under the ice shell of Titan, at a depth of about 100 kilometers, there is an ocean of liquid water. This is indicated by some irregularities in the oscillations of the moon in its orbital motion. Photographed by the Cassini in various spectral ranges, the surface of Titan in the tropical latitudes is divided into several bright and dark regions with clear boundaries. Near the equator, on the leading hemisphere, there is a bright region the size of Australia, which is high ground, probably a mountainous area. It was named Xanadu. In general, the surface topography of Titan is relatively level. The variation in height is no more than 2 kilometers. However, local changes of elevation, as shown by radar data and stereoscopic images obtained by the Huygens, can be quite significant. Steep slopes on Titan are not uncommon. This is the result of intense erosion in conjunction with wind and liquid. There are several objects that look like impact craters, presumably filled with hydrocarbons. Many craters may have been buried under a layer of sediment or were quickly smoothed over by intense wind erosion. The surface of Titan in the temperature latitudes is less contrasting. Titan has distinct indications of volcanic activity. However, Despite the similarity in the form and characteristics of the volcanoes, it is not silicate-based volcanoes that are at play on the satellite, as on the Earth or Mars and Venus, but what are known as cryovolcanoes, which most likely erupt with a water-ammonia mixture with a touch of hydrocarbons. Unlike the Earth, in the course of the change of seasons, powerful clouds of Titan move a great deal more along the latitudes, while on Earth they move north or south only slightly. Disappearing islands on Titan have also been a huge mystery for years. The largest of them is in the mysterious seas of Kraken Mare. The depth of the seas ranges to several hundred meters. Studies of the sea, Ligia Mare, have discovered an unusual feature: bright island-like objects that appear and disappear in some radar images. Moreover, there aren't any significant waves on these bodies of water. There are two explanations of what they can be: gas bubbles or solid floating formations. It turned out that at the surface the mixture exists in the form of one phase, but at a depth of 130 to 170 meters, the ternary mixture's state changes into a combination of two liquid phases and one gaseous. The solubility of nitrogen in ethane is much lower than in methane. It is emitted as a gas. Chemists estimate the diameter of the average bubble at 4.6 centimeters. This size is apparently enough for them to be visible to the radar. Nevertheless, researchers would like to note that there is not enough data to give an accurate description of the processes occurring in the seas of Titan. For example, the temperature and exact composition of the seas are unknown. More accurate data may be provided by future missions to the Moon. A new target of research is Saturn's moon Titan, to which the Dragonfly mission will be launched in 2026. It's expected that in 2034 the 8-rotor drone will land on Titan, which will receive electrical power by means of a thermoelectric generator. Becoming an eyewitness to these new discoveries will truly be an exciting and amazing time. Cassini fell through Saturn's atmosphere at a speed of 124,000 kilometers per hour. I wouldn't have wanted to be on top of the space probe at that moment. After all, no one knew how long it would last, since the study of the interior of the planet had not been the original intention of the scientists. Finding itself under the rings, Cassini snapped as many images of Saturn's clouds from as close as possible. But most of all, scientists were astounded by the giant hexagon, a huge hexagonal vortex, and more than that, one side of this hexagon is equal to the diameter of the Earth. It is present only at the North Pole of the planet, is comprised of thousands of smaller vortices, and in the very center of the hexagon is a giant funnel that goes deep into the bowels of Saturn for several hundred kilometers. The hexagon itself, depending upon the season, also changes color. It can be greenish, golden or blue, but the hexagon's shape remains stable and has lasted for hundreds of years. The seasons on Saturn change as on Earth due to the tilt of the planet's axis. When Saturn's North Pole is tilted towards the Sun, it receives more light. The sunlight interacts with the atmosphere and forms particulate matter, aerosols. It resembles smog. Therefore, it tints the hexagon with a golden-orange color, and when Saturn turns away from the Sun for the winter, the hexagon darkens. The central funnel is always a dark blue, regardless of the season, probably due to the fact that a mist of aerosol particles is drawn in there like a vacuum cleaner. The symmetrical shape of the hexagon is due to the interaction of the planet's rotation and atmospheric currents. At the end of its mission, during the closest approach, Cassini transmitted photographs of these roaming vortices one after another in excellent quality. But how old are the rings? Have they existed since the birth of the planet itself? Or did they appear recently? At the end of its mission, Cassini gave us the answer to this question. We were very fortunate not to miss out on this marvel of nature. They are only 10 to 100 million years old, and it is possible that at the end of the time of the dinosaurs on Earth, Saturn was not yet the Lord of the Rings, as they are too light and too bright. If they were ancient, they would have already long ago become covered with dust and turned much darker. Apparently, Saturn pulled an icy moon like Enceladus towards itself, and its gravity destroyed it, tearing it into small pieces. They were dispersed into orbit, constantly colliding with each other, as a result of which they were shattered into small fragments, and the sharp corners between them became smoothed out like pebbles on the seashore. Cassini showed that the thickness of the rings varies extremely. There are millions of rings, and between them there may be gaps, but the rings themselves look like a vinyl record. The only thing we need to do is to find an interplanetary scale record player. Yes, Cassini has died, but its legacy lives on and still excites. The final images of the hexagon, the discovery of freezing rain, the study of the appearing and disappearing vortices, and the discovery of shepherd satellites showed us that Saturn is a single system. Yes, by looks it seems beautiful, and at the same time harsh. But this is an incredible world where everything is well balanced, from a small curl in the atmosphere to the finest specks of dust in the rings. Saturn is a unique creation of nature, and Cassini showed us that the whole world of this giant planet rests on the delicate balance of gravity. Only unity and harmony could have created such a true masterpiece in the universe. These were Cassini's final words.
Mars, by distance, is the fourth from the Sun, and by size, the seventh planet in the solar system. We have seen the unique landscape of Mars. The extinct Martian volcano, Olympus Mons, is the tallest mountain on the planet, and the Mariner Valley is its largest known canyon, and there is a huge number of impact craters. Mars has a rotational period and a change of seasons similar to the Earth. Nonetheless, relaxing under the palm trees, which don't exist here, isn't going to happen. The average temperature on Mars is minus 40 degrees Celsius. To this very day, we are receiving a huge amount of data, some of which we already want to share as early as in 2021. 1. Before you are the white clouds that occasionally appear in the upper layers of the atmosphere of Mars. And as we know, clouds do not form on their own. For their formation, something is required to help the water condense. For a long time, climate models simply could not explain how they could have formed at this sort of altitude. The process consists of what is known as meteorite smoke, whose burnt residue helps the water vapor condense and turn into small particles of ice. This discovery prompted the thought that the fine dust that rises into the atmosphere after the meteorite smoke may play a role in the creation of Martian clouds, very similar to how glowing noctilucent clouds appear in the Earth's mesosphere. Three, another interesting discovery was the glaciers of the Red Planet, which do not remain in one location, but move down the slopes of mountains or across the plains, retreating and advancing as the temperatures rise or fall. These movements of the ice do not occur without leaving a trace on the surface of the planet.
very distinct landforms appear on it, such as fjords, drumlins or rounded hills and other objects, which make it very clear that at one time a glacier existed here. Thanks to images from the MRO, or the Mars Reconnaissance Orbiter, over a period of several years, it was established that glaciers move in the form of massive streams at a speed of 300 to 800 meters per year. However, on the Tempe Terra, located to the north of the Tharsis volcanic plateau, the probe managed to find what are known as eskers, rather low and very long hills, similar in shape to railway embankments. Eskers, unlike many other glacial landforms, are formed not as a result of the movement of the ice itself, but rather of the meltwater flows, which spring out from between the edge of the foot of the glacier and the ground, and carve narrow but long channels, tens of kilometers in length. Four, the so-called Noctis labyrinthus, or labyrinth of night, is also worth pointing out. We have heard about it more than once. However, there is something that's brand new. Yes, this is an amazing place, but I still wouldn't want to go there. It turns out that in the past, this canyon was one of the deepest gorges on Mars, which was filled with volcanic lakes. Studying the images of these canyons, researchers came across hundreds and thousands of dark lines, similar to those they had seen 5 years ago in the high latitudes of Mars. The appearance of these lines, judging by the images, led to large-scale changes in the appearance of the surface of the Mariner valleys. According to calculations, their appearance indicates that the soil of Mars in this region held or absorbed about 1 million cubic meters of water. Five, let's turn our attention to what are known as the sand spiders of Mars. No, they won't eat the settlers for a snack. They aren't that kind of spiders. But some things we know for sure are that Mars, just like the Earth, has its own weather, system of air currents and climate. And these canyons, or spiders, as observations have shown, are constantly increasing in size. What causes them to grow? Actually, Martian sand dunes and deposits of dry ice, the frozen carbon dioxide that cover the dunes, facilitate the formation of these landforms. In the summer and springtime, when the air and soil temperatures on Mars sharply increase, a portion of the ice warms and melts. As a result, the dry ice turns into carbon dioxide. A giant bubble of gas appears under the surface of the glacier, and the pressure in it increases. After some time, it reaches a critical point. The ice bursts open, and the CO2 is ejected into the atmosphere of Mars through the fracture. Together with the gas, a massive amount of sand falls onto the surface of the dust-covered ice, which, due to the high pressure, turns this air geyser into a sort of sandblasting machine, stripping away the surface. Therefore, the cracks through which the gas escapes grow each season and turn into the giant spiders, which can be seen in the MRO, or the Mars Reconnaissance Orbiter images. It's difficult to come to grips with the fact that 4 billion years ago, Mars probably resembled the Earth. That means its vast expanses were most likely covered with a shallow ocean, perhaps several hundred meters deep, but not kilometers, as on the Earth. Clearly, there was water. There is already no doubt about that. However, billions and billions of years passed, and Mars rapidly died, becoming cold and losing almost all of its atmosphere.